All right, continuing on with the system in this video here, Lee's going to be implementing the fine patches and deform mesh.
Yep. Well, actually, there's a little bit more to it. It was just kind of notes so we could keep track of what we needed to do.
Right?
We've implemented the brush now, and we've implemented the tool, but there's some stuff that we have to do in the TerrainSculpter that deals with when to call the deform mesh and what to send it. So we've got some cleanup stuff to do there, as well as set up a delay timer. Because right now the way we've got the code set up is that this thing is going to run as fast as the frame rate on your computer will allow. What this ends up resulting in is on a slower computer, you sculpt very slowly, and on a blazing fast computer, you sculpt at insanely fast speeds, which are pretty much unmanageable.
Mm-hmm.
So what you would get is like on a machine like mine, where I would be sculpting with, strengths and opacities in the 80 to 90%. You would be trying to get 0.01% on your strengths and opacities just to keep it under control.
Right.
So what we're going to do is we're going to put a delay timer in,
Mm-hmm.
which will force the painting to hold at about 30 frames a second,
Okay.
just so we get the illusion of nice smooth painting, but that it's consistent across machines, so we don't have that wide difference in settings just to make the tools work right.
Right.
So now, where to begin? I guess we could start with the delay, because that'll be the easiest one to put in to start with.
Okay.
So if we go to the TerrainSculpter, we scroll up to the top, we're going to need another constant. So private constant, this will be a float delay. And we're going to set this to be 0.33f, or 0.3. So, and if we bring up the calculator,
Yeah, I just,
yeah, type it.
that.
Yeah.
There you go.
I was wondering if it was up there. All right, so if we take, what is it, just 30 frames a second. So if I were to take 1 divided by 30, that didn't work, right? 1 divided by 30, what happened? 1 divided by 30. Okay, I know how to work a calculator. Okay, there we go. There's our number. So if I want to run at about 30 frames a second, that's how I derive that number. Okay, continuing on after my calculator.
Snafu.
Yeah, well, at least we weren't trying to calculate percentages. Well, I think that is a percentage. But, man, wait until we get into sky modeling. All right, so we need to make a new static float delay timer. This is going to hold the value that we're going to be incrementing or decrementing. Technically, we'll be decrementing it every update to determine whether or not we're going to be allowing the next update of the terrain sculpting tool. So after we go here, but before we do enable, so I want this counter to always count down, even if we're not enabled. So as long as the counter is something greater than 0, it's going to count down, even if we're not enabled. That way, the moment we enable the tool, it'll start painting immediately or sculpting immediately. So we'll say if delay timer is greater than 0, we're going to go ahead and decrement the delay timer by time dot delta time. Then if we scroll down to our handle sculpt tool, down here where we deform our mesh, we'll go ahead and do an additional check that will say, hold on, there we go, if delay timer is less than or equal to 0, then go ahead and deform the mesh and reset the delay timer, which will set to delay. Oh, not to itself. All right, so that will reset our delay timer. So the next time through, we end up with our slower update, so it's not going at the full frame rate of the computer. All right, that takes care of that part. The next thing that we need to do is handle our, when we call our deform mesh, getting rid of this null. To get rid of this null, we're going to need a list of patches. But right now, there's nothing in our code that will give us a list of patches, so we need to create something to do that. So we're going to go over to the train patch, and we have something that will give us a single patch. So we can go through here and get our a single patch, but nothing that'll give us multiple patches. So we're going to create something to do that. So this will be a new method that's going to be a public static. It's going to return a list of terrain patches, and we're going to call it find patches. It's going to expect a vector 3, POS for position, and a float width. Now the width is going to be the brush size. So what we're doing is we're telling it the brush is going to be at this position. It's got a width of this, which I think I'm using width or brush size divided by 2 for that. But we're basically doing a, what's the word, a collision check, for lack of a better term. We're just taking the rectangle that's formed by the position with the negative width on X and the negative width on Z, and then the positives of the same, and figuring out what patches are actually contained inside that rectangle. Add all those to a list and return that list. So we're going to make a variable called offset. This is going to be equal to our size minus 1 times spacing divided by 2f. Now this is calculating out the size of our patch divided by 2. So an offset is going to give us the half width, if you would, of our patch, which we're going to need to compare against the values we calculate from here. Now, I'm going to return patches there we go, I can spell. So we're going to return patches where send it, I'll have to add that later. All right, where, oh, there it goes. Where terrain patch goes into position.x plus width divided by 2 equals or is greater than or equal to terrain patch dot position dot x minus offset copy this. Oh, not the whole thing. I don't need this part. All right, and position X minus width divided by 2 is less than or equal to terrain patch position X plus offset. And if I copy these two up to this point, whoops, the whole thing's going to have to get converted to a list. Now let's go adjust these two. This is going to be position Y plus width divided by 2, and that's going to be minus, so that's right. No, not Z, not Y. What am I thinking? All right, so these will be our widths plus and minus, and terrain position dot Z minus offset, terrain position Z plus offset. So this is going to calculate which patches fit inside of our rectangle. So we're just doing a collision check. If it is, it gets added to a list, which we're returning. So once we've got our list, we can go back to our TerrainSculpter, and now we need to get that list. Or we have the ability to create a list. We need to actually call on that ability. So if we go back inside of here, now I don't want to do the list all the time, and I only want to do the list when we're inside of our timer. And I also want to only generate the list if certain conditions are met. But we'll start with generating our list. So var patches equals terrain patch dot find patches. We pass it our position and our brush size. So we're doing the divide inside. So we don't need to divide it here. All right, so that will get us a list of patches. Now, when do I actually want to do that is only going to be if our input dot get mouse get mouse button down and send 0. So whenever the left mouse button is down, and no, I'm going to leave that out for now because that deals with camera systems, and we don't have that yet. So I'm going to leave that out. All right. So if I build that out, we take our patches that we go get and we replace that with null. Now we should have everything in place to go through, detect when we're actually over our terrain, and our delay timer is ready for the next input, and we're holding down the left mouse button. It'll go get a list of all of our patches, called deform mesh on that list of patches, and give it our position. And we call the static deform mesh with our list and positions, which basically goes check our sculpt tool, make sure it's not null. Just for consistency, we should probably also check our brush and make sure that's not null as well. it won't be because we defined defaults, so we should be okay. And then we take our patch list, we pass that down to whatever our sculpt tool is, along with our brush, our position, and our brush size. And let's see. Actually, I don't need position here because I'm now doing it this way, because this is a static. So I can kill. No, that still needs to go here because that needs to get passed off. But I no longer need to call position here because I have access to it because it's a static class and position is static. So just like we have brush size here, we've got our position. Why is my brush size a variable? Because position is a static. And yeah, okay, that'll work fine. Just trying to figure out why I did a field for one and a property for the other, because one doesn't ever need to be accessed externally.
Okay.
All right, so that should take care of everything that we need in place as far as going through and adjusting stuff. I'm trying to think, would that work? No, we still don't have enough in place to show anything. Where we could run this and paint and sculpt, it would do all the jobs, but we wouldn't see anything visually, not until we complete the next video.
Okay. So then with that, is that one going to pretty much wrap this one up?
Yep, that's the end of this one. So the next one, we will now apply our mesh updates. And then we should be able to see the results of all this hard work.
Fantastic. Well, with that, that will conclude this video.